Welcome back to another science video about waves. I'm Jeremy Krug, and in this video series we're looking at waves, and in this video especially electromagnetic waves. Now, when we talk about electromagnetic waves, these are a little bit different than the other waves that we've talked about so far. Most other waves that we've discussed, like sound waves and earthquake waves and ocean waves, these travel at a relatively slow rate of speed, and they travel through a medium that involves traveling through some sort of matter. Like sound waves usually travel through air. Ocean waves travel through water, of course. Earthquake waves travel through the earth. Well, electromagnetic waves are different. They can travel through a medium that is basically the vacuum of empty space, unlike other types of waves. Also, electromagnetic waves travel at a much higher rate of speed. They travel at the speed of light. Now, when we talk about electromagnetic waves, probably the most common one that we think of just in our everyday life, would be visible light. So the light that's shining on my face right now from the light here in the room, that's electromagnetic waves. That's a good example of that. Or we could think of a light that we shine out of a flashlight or a laser. That's an electromagnetic wave. But it's not just limited to that. We can talk about radio waves. We can talk about X-rays, microwaves, gamma rays, ultraviolet radiation, infrared light. These are all examples of electromagnetic waves. They all travel at the speed of light. And if we want to send them through the vacuum of empty space, we can do that, unlike sound waves, which cannot travel through a vacuum like that. Now, the speed of light is just about as fast as we could go. In fact, as far as we know, that is the speed limit, the highest speed at which anything can go in the universe, as far as we know. The speed of light is 300 million meters per second. Now, that is really fast. Now, sometimes it's hard to wrap our head around that, especially if we're not familiar with numbers that large and the term meter. So if you're used to using miles, we could call that about 182,000 or 186,282 miles per second. That is very, very fast. We're talking about something on the order of about 7 times around the Earth in 1 second. Very, very fast. Or, if you want to use miles per hour, about 671 million miles per hour. In the last video, we talked about the difference between the speed of sound and the speed of light. How much faster than sound is light? Well, light travels about 874,000 times faster than the speed of sound in air. So we're talking about an extremely large difference between the speed of these two things. Sound is comparably a tortoise or snail compared to light. Now, let's take a look at the electromagnetic spectrum. So these are the different types of electromagnetic radiation we talked about and how they compare. So in the middle here, we have visible light, and we have those colors, which we'll talk about a little bit later. But notice that on the very, very high frequency, very high energy, but very short wavelength part of the spectrum would be gamma rays. Now, if you've taken my chemistry class, then you know that gamma rays are the most deadly and most dangerous part of the electromagnetic spectrum, generally speaking. You can actually be fried from those. X-rays can be rather dangerous as well if you're overexposed to them. We know that in small amounts they can be useful for medical imaging and things like that. They have a little bit lower frequency. Ultraviolet is lower frequency still. And then we have visible light. And so we have that in there, which we're familiar with. Infrared has lower frequency still and a longer wavelength. And then we have microwaves. We have heard of those. We know what microwaves are used for. And then at the lowest frequency of the electromagnetic spectrum, with the longest wavelength, we have radio waves. And when we say radio waves, we can include TV waves in there too. So TV that's broadcast over the air and picked up with an antenna, that would be in the fairly longer wavelength part of the spectrum. So we have all of these that you want to know about: gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. Now, let's focus on the visible light spectrum, because that's the one that we're probably most familiar with. We have learned about that before. Maybe in elementary school you learned about the colors, and we have what we just commonly call the 7 most common colors here on the visible light spectrum, and we can remember those in order with the little acronym ROY GBIV, right? Red, orange, yellow, green, blue, indigo, violet. Now, if you want to cut in between here, you can see that there would really be an infinite number of colors almost, aren't there? But sometimes we like to split this up into some colors that we can distinguish. And of course, if you have red, well, that has the longest wavelength and would, as a result, have the lowest energy. On the other hand, violet over here has the shortest wavelength and has the highest energy. And so there are some solar calculators or solar cells that if you shine a red light on it, it's not going to actually cause the calculator or the solar cell to activate as much, at least. On the other hand, if you shine violet light or purple light, or certainly an ultraviolet light on it, it's going to perk right up and actually start to generate quite a bit of activity there. So we can actually see that different colors of light actually pack a different amount of energy in their waves. So we have ROY GBIV, red, orange, yellow, green, blue, indigo, violet. And of course, next to violet, if you go just a little bit beyond that, we have ultraviolet. And we can say the same thing for red. Just beyond red, just outside of the range that we can normally see, is infrared. And so that's a little bit beyond red. Well, I hope you learned a little bit about electromagnetic waves in this video. If you did, then please give me a thumbs up and join me again on my channel where we can learn some more science together.